Okay, you're on.
Okay. Hi Dan, we are in review mode here, but before I go to physics, I have something to say to you about math. I forgot to give you your math test, and you snuck off to Florida without it.
Dan!
So anyway, it's my fault. So Miss Kim Davis has tried to electronically send it to you, so we check around and see if it's made it. I can take a picture from my camera and get it to you. So let me know about that. So somehow we'll get you a picture or an electronic copy of the test. So never fear. All right,
Don't fear,
into
Dan.
review mode in physics class, so we're learning a new thing because the author of our test loves these kind of questions, and they will be on every test from here on out. So this question points to the range equation, and it says what would happen to the range, so we're wondering what happens to R if G is cut in half. So the answer is like this. Your mathematics comes out to help you. So what you're going to do is you're going to put a 1/2 in front of G because it says if G was cut in half. So I'm going to go 1/2 times G, but your mathematical sense, you know if you do something to one side of the equation, you have to do it to the other. So this 1/2 is in the denominator, so I'm going to go over here and do the same thing. You see I have done the same thing on both sides. 1/2 G because the problem pointed to that, so I had to adjust by doing the same thing to this side. So what is R divided by 1/2? You flip the 1/2 and multiply it by R, and you get R is multiplied by 2. So R divided by 1/2 is the same as R times the reciprocal 2R. So the answer to the question is the range is doubled.
I'll put that. Good job, Ryan.
All right, you probably could have reasoned that without the math, but there will be ones where you need the math to do that. So if you cut this in half, this becomes a doubled number. Make sense? All right, if you got it, we're going to do another one of those, so we keep practicing. If you got that, it's B4.
For what?
All right. This time, we are going to, what will happen
Don't
to,
move it around. Leave it in there.
we're going to take the same equation, the range
It's
equation.
not fault.
What will happen to the range if the velocity is tripled? So write that down.
Oh my gosh, why is this camera being like
Because
this?
you kept moving it. Don't move it.
I'm gonna hold it like this for the
Jenny,
rest
you have to pull the leg down.
Hold the thing. Daniel, hold the thing out the other way.
Got it.
Just leave it. Just don't mess
Don't
with
touch
it.
it, don't touch it.
Don't touch.
Go, look, it's touch.
Good looks. Is that the best you could come up with?
Wow.
That's something a lot of people say,
It's a good thing this is recorded,
Why?
because the world can hear my sass.
You were not fast.
Okay, ready? We on? We're still on? What was wrong?
Nothing.
They
Okay.
tried.
All right. New question, same equation. Write it down for study and see if you can reason through this one. What would happen to the range if the velocity is tripled?
I don't
I know, but he can't see the equation. Chill. There, it's all good.
Daniel's fine. Stop touching him.
Whoa! That was on record too.
What would happen to R if I go in here and triple the velocity? Let your math help you answer that.
If initial velocity triple.
Yes, initial velocity. I'll put that in, initial.
Wait, is this still supposed to be recorded? I'm a terrible
I
camera
need to
man.
kind of watch the time so I can turn it off, say about quarter after, you think? Without going over
Yeah,
15
He
minutes.
started a few minutes after.
It's all good.
So
Oh, really? We did? Wow, so it's already been maybe
maybe
5 minutes, I guess quarter after will work then. All right, let's talk about it. So I'm going to go in with my tripled my 3, and I'm going to put it right next to the V like that. But notice when it hugs the V, the 2, the squaring, will also be applied to both the 3 and the V. So if you have an adjustment to make, make it quickly. Everyone's erasing. So the 3 is hugging the V before it's even squared. So now I'm going to think, well, 3 squared was really a change of 9. So I went in here and actually put a 9 in front of the V. And so that will cause me to do a 9 on this side. So the range was multiplied by 9. So these aren't bad once you get the gist. Range is multiplied. We'll do one more.
Why would it be if it's v sub o times 9, wouldn't you divide by 9 on both sides?
No, it's equations work like this. If you multiply by 9 on this side, you multiply by 9 on this side. So I'm not solving that. If I was solving it, I would. But I'm multiplying on both sides, keeping the equality. All right, let's try. Say, what would happen to the range if the initial velocity is...
You never gave them a...
Oh yes, I'm thinking. All right, we will do N2.
Miss Powell,
Uh-huh.
do you want those numbers on the left side in the thingy?
No, that's okay. That's all right. What would happen to the range if the initial velocity is multiplied by 15? We're really going to speed up this problem. All right, here's the range equation.
Yes.
So I'm going to go in and make this object go 15 times faster than I did before. What will happen to the range?
Not sure.
What will happen to the range if the initial velocity is multiplied by 15? So I'm going to go in with my 15 number. It's going to hug the V before it's even squared. So now I'm going to apply the square to the 15. So I'm really multiplying this side by 15 squared. And I just did that. I forgot what it was. 225. So I'm going to multiply this side by 15 squared as well. So that's 225. The range is multiplied by 225. All right. I think that you got the gist of it.
Yeah.
Whatever I do to this side, I do to that side. If I do it in the numerator here, I do it in the numerator here. If I do it in the denominator here, I do it in the denominator there. all right, there will be questions like that. All right,
What's that number?
that one will be 04.
We already had it for.
No, we did not.
I don't have any O's yet.
We
That's not
had
up there.
B4 and
Oh, yo.
I4.
They're listed up there.
Yo-yo.
Data for the record, we did not have 04.
Yeah, we did.
Crystal.
Haley,
The one
Haley,
from
you
the
just
vendor up there.
ruined the entire video.
Jenny, you literally been shaking the camera.
Yeah, earthquake over
Daniel
there.
something.
Earthquake did. Did you think this was an
Daniel, the other
earthquake?
Here's a question, a theory question, then we'll go back to math. All right, write this
Bless
question down.
you!
If air resistance were included in the range equations, it's not. If air resistance was, or if air resistance, if air resistance was included in the range equation calculations, how would the range change? A little poem.
The range can change with no seed change.
All right, up till now, we've been pretending there's no air resistance. Let's say we are adding air resistance into our calculations somehow. Someone's going to teach us how to do that. Do you think that air resistance, what will it do to the range when we start calculating it in? Is it going to increase or decrease, basically? So put your answer down without sharing it. And I'll write that on the board. How does air resistance affect R? So we're gonna add that into it. Did you say that air resistance will decrease the range?
Yeah.
Because it's gonna slow it down. It's going to go through all these air molecules and bump into them, and it's not gonna go as far. So R decreases. All right, if you said that, you may cross out N1. Okay. Let's do a math problem.
Haven't we been doing this the entire time?
Math problems? We just did theory problems with,
Oh.
there was a little math though, I agree. Okay. The boy stands on a hill. The hill is 15 foot high. The boy stands on the hill, it's 15 foot high. And he's got a slingshot there, and he's going to launch a rock at a target that's 108 feet from the base of the hill. The rock will leave the slingshot at 0 degrees for an angle. What is the rock's initial velocity? Find V sub O. So this is two-level living, so you know what equation to start with. Is this a question in X or Y? Because it's coming out.
Y.
It's only coming out with one direction at first. So initially, the only velocity we have is in the X direction before it starts to tumble downward. So we are going to do it in X first till we hit a blockade. And we're using always which equation for two-level living? Okay. So we're going to do it in terms of X and go as far as we can. And then we're going to stop because we won't have enough information. And we'll go and do the voter in terms of Y. And down here, we'll get the information that we need to go back and finish. These are the kind we were just working on last day or two, so.
Is this in feet or meters?
It says feet, these little marks. Alright, I'm going to start this journey on the board. Try to ignore me. And you can look up if you're stuck and see what's happening.
How long has
So-
the video been going? It doesn't say.
15 minutes now.
Okay, we should.
Yeah, okay. We need to shut down the video and start it again.